Hello, and welcome to 5-Minute Math. Today we are looking at the Algebra 1 concept of rate of change. This is standard A.3B in the great state of Texas, and we are using item number 7 of the 2024 released STAAR test. If you haven't done so already, please go ahead and take a moment to pause the video, work this problem out on your own, unpause it, and we will look at our answers together. All right, so we have the graph of a line. And it's represented by this equation, this 5x minus 8y equals 40. And we need to find a value that represents the rate of change of y with respect to x. All right, so what do we know about linear equations? And this is a linear equation because there's no exponents. It's not a quadratic. It's not an exponential. We see linear equations there. And we see that really what we're looking at is we are looking at a standard form. So they've given it to us right there, standard form, and it's that ax plus by equals c. Now we're looking for the rate of change, and hopefully we know that the rate of change, and this is the big jump that we have to make in this problem, rate of change can also be described as the slope. So the slope describes is if the line is moving up to the right, if it's moving down to the right, and at what rate. Is it a steep slope or is it a shallow slope? That rate of change can best be represented in this right here, the slope-intercept form. This y equals mx plus b. And really, it's just going to be this m right here. That's my slope, or I can also call that my rate of change. So here's what we really need to do. We need to take our equation that they gave to us, this 5x minus 8y equals 40, and if we could make it look like this, we would get our rate of change. All right, so how do we make our standard form look like our slope-intercept form? Well, what we need to do is we need to solve for the y, because notice in our slope-intercept form, we've got y isolated over on the left. So let's do that. So how are we going to solve for y? Well, first I want to subtract 5x from both sides. Right, I'm doing reverse PEMDAS here. So when we are isolating, we are going from the bottom up. And so this 5x, that is positive 5x, that's just being added to this negative 8y. That's the easiest way, because when we are isolating, we go from the bottom up. So 5x minus 5x, obviously they cancel each other out. What I'm stuck with here is negative 8y equals, and I'll go ahead and put that negative 5x in front, plus 40. Now, you notice we're looking a little bit closer. What's next? Well, I've got this negative 8 times y. And since negative 8 is times y, that's what we're going to deal with next. The opposite or the inverse operation of multiplication is going to be division. So if we are multiplying by negative 8, let's divide by negative 8. So negative 8 divided by negative 8, it just becomes positive 1. Now my y is isolated. So I've got this negative 8. What I want to do is I want to distribute that. So I've got negative 5x over negative 8. So I've got a negative and negative. It just ends up being a positive. And then I'm going to go ahead and put a minus here because it's going to be 40 over 8. 40 over 8 is 5. But it was a positive 40 and a negative 8, so it ends up being minus 5. So here's my final equation. Y equals 5/8 x minus 5. That's the exact same as this right here. So what is the rate of change? Well, it's going to be my 5/8. And you notice everything here has to do with 5 and 8. Just depends on what's in the numerator, what's in the denominator, and whether it is positive or negative. But we see our answer here as C, and so we're going to select C, 5/8.